Hello everyone. This is not a test today, this is real. Um, this is the first stream of a series. So basically, as some of you might know, Phaze101 used to do things for the Amiga about 30 years ago, but um, then we stopped and we started doing things on the PC. We were part of the demo scene at that time. Uh, the how to say, the funny thing about it is that we returned. I mean, funny in terms of I started. Um, I was doing things. I was writing games on the PCs, for the PC and Android and all that stuff. But I did not find any satisfaction in doing that. And I jumped back to the Amiga, to the retro scene. Initially, nobody of the members of Phaze101 wanted to join me, and they laughed at me when they told me I'm crazy. Um, but now, most of them are back. So yeah, unfortunately, we do have some of the sources, but not everything. We lost most of the stuff that we did. Um, However, looking back and trying to understand our own sources is a nightmare. I really cannot understand what we did, and I'm not up to that level as I used to be. Um, However, we're trying to get there, um, and I mean, I think our view is not anymore about making demos. It's not. It's not that what interests us anymore, but it's making games for the Amiga or for the Commodore, because I like the Commodore 64 too. So um, yeah, for those two machines in my case. I think the other members are more interested in the Amiga and making music um, more than me, coding for the Commodore 64 and for the Amiga. So this stream, as some of you might have noticed yesterday, first of all, before I continue, can you hear me? Because that is something that I forgot to test. I hope that the sound is okay and you can hear me properly. Can you please type yes if you are following? If you can hear me, can you please type yes? So to make sure that everything is okay. I take it it's a yes. Okay. So basically, we will be going through our own sources, which are 68,000 sources, and uh, basically trying to go through them and understand them. I can assure that some of them are in a very bad state. In the sense we didn't write comments at the time. We you know we were not as good as we are today. We were kids, no? So you can imagine to what level our coding standard was, no? So yeah. Anyway, um, so the aim of this stream is to, let's say, reconnect with the 68,000. I probably will continue doing this type of stream because I um, want to learn 68,000 as fast as possible. And the Amiga, I mean, not to be, you know, a professional or something like that, far from it. I'm really far away from being like that. But to be able to have fun on it again, because right now um, I'm not able to reach the level that I used to. I do not have the knowledge that I used to know. So that's the main reason why I'm doing these streams. Of course, there is the stream that I do every Sunday, one in English, one in Italian, about from the book of Fabio Cucci, sorry, um, in relation to 68,000 programming for the Amiga. But this is an add-on. Um, it covers things, or it has things that maybe they are not in the book. And yeah, how to say, the reason behind it is to I'm taking the opportunity to learn what I did or what we did 30 years ago, and at the same time organize my sources and have some fun as we used to have back in the old days. That's basically the main reason behind it. Okay, so let's give you an overview of where of what we have. So actually, I'm going to use, so different from Sunday, I'm going to use Visual Studio Code, as you can see here on the screen. I need to make the font a bit bigger. Yeah, I hope you can see it like this. Please tell me if you can see it. I mean, it should be fine at this size. Yeah, and besides that, we're going to use the Amiga. So I will be editing the code on Visual Code, but what I'm editing is what's on the Amiga on my. So I'm sharing a directory between the Amiga and Windows where I can basically edit the code in Visual Studio, Visual Code, not Visual Studio, and run it, assemble it on the Amiga. Why I'm using, I could have used a cross development environment. Why I'm using this is because the sources are so old and some of them are written with C assembler. So Vesim does not support Sika. As Vesim is, as far as I know, compatible with um, DefPack. So because most of our sources were written in Sika and DefPack, I have chosen to go for as in one, somewhere in between both words, let's put it this way, and assemble everything on the Amiga directly. Anyway, my emulator is quite fast anyway because it's virtual. It's what it is. It's so give me a second, guys. I need to check something. The stream should be okay. Yeah. I'm just checking that before I start talking and going into the, so that other people will not be left out. That's the main reason more than anything else. Okay, it seems all fine. Yeah. So a note for those following me on Facebook instead of Twitch. You can follow me on Facebook. However, anything that I share, you will not be able to see it or get it. So links and things like that, you will not able to get them on Facebook. You can only get them through Twitch. So I believe on Facebook I shared the link to my Twitch. So please, if you feel more comfortable, please come to to Twitch, and if you like what you see, also please help me out and how to say, follow us if you like this series. So I'm going to start with the first source that I have. Yesterday, I started working on alert 1, but I'm going to work on alert 2. And the reason why there is more things on this one than in alert 1, yesterday it was a test. So I'm going to start again from the beginning of what I said yesterday. So the first thing we're going to need is the Phaze101 manual, and we need to look for section. Let's try to make it that it doesn't take the full screen. Okay. Let's see if I will be able to. That's too much like that. So Control F, and let's look for section. So basically it's written with Sika assembler. This one was a directive of the Sika assembler, but of course Phaze101 doesn't support this directive. So I need to basically find the equivalent to it, which is section. So this is the Phaze101 manual. So I'm looking for section and see where it is explained. Okay, can you see the screen? I'm assuming that because I haven't seen anyone complaining, I'm assuming that all is fine. So section has got a label at the front, which we do not need, then the word section, then a name, which can be a string, any string, and then the type. Now type can be code, data, or a container, basically, where you can have the data. However, you can also specify in which part of the memory your code or data goes. So you can add _p for public, _c for chip mem, and _f for fast memory. So we are going to use public, so it will be code _p. Okay. So section. Because we do not know yet Phaze101 code, let's put it this way. Let's give it that name, and then code _p. Okay, I will start inserting comments while we are doing this, just to prepare this code. I believe this code was written by Crane. So I'm going to say original code by Crane /Phaze101. And now update it by Prince /Phaze101. I will do date. I better do date because so I'll just do November 2020, and then we'll see what it is. Okay, I am going to skip the first part. Okay, I saw something that I do not like, which I will tell you later on. It was not there yesterday, but this one, alert 2, has got it. Yesterday it only had till here. tilde BNE, but now it has this part which there's something that I really do not like. But anyway, let's start from here. We'll have to return to that. So it's not an issue. It's just that I'm trying to skip something that I think it's dangerous right now. So the Amiga starts always from address 4, okay, and it loads everything, starts and I mean it's when you switch it on, the first address it looks at is address 4, and from there it loads. It's where Kickstart, let's say, is located, and then it starts booting, etc. However, remember, Kickstart is a group of libraries too. It has got the exec. So address 4 is the base address for the exec library. So we can say that this is exec base stored into A6. Now, this command can be written in a bit much more nicer way, and also takes less memory. So first of all, we use hex, and then we use .w. Okay, so because it's a low memory address, it doesn't need to be a long address. So that we are forcing the assembler to use a small address, which is a word, which it can do, this 68,000, so it's not an issue, okay? And like that, it takes, so A6 is is part of the instruction, okay? This is 2 and this is 2. So basically we are saving quite a bit because we are only using 4 bytes, if I'm correct, because this is 2 and this is 2. I mean, the instructions of the 68,000 are always 2. And because A6 is part of the instruction, so it must be one of those absolute addressing mode, and then there's one of them. Okay, so now we are using load effective address of this label here, which is the intuition library. So I'm going to change the name a bit because address 1 doesn't really make that much sense, and I'm going to call it lib and then intuition. Or lib, I can use lib name too, lib int name, let's see, better, I think. Okay, and so we change this here into lib int name. Now, the extension that I'm using, I forgot to mention in Visual Code, is the Amiga assembly extension for Visual Code, and it is right now is version 0.20. So it's not yet complete, this extension, and actually it does use VASM and it does use FSUAE to cross compile, but I don't want to say I didn't like it. It just cannot handle multiple files. It can only handle one single file. It's difficult to handle includes with it and all that stuff because it's not mature yet. So it's another reason why I'm not using cross compilation on in this series. But as long as it can highlight the code, etc., it's fine. And so just to continue, we are loading the name, the address, okay, the address of our string into A1. So lib name into A1, and the libraries has got a specific name, so you need to call them with that name. Okay, intuition.library, that's the name. Okay, and remember, define constant dot b is define constant byte, which, so we are passing a series of bytes, and since it's a string, it needs to be null terminated. Okay, and for safety, I'm putting the even, so instructions always start at the even address, at an even address, because that's required of the 68,000. It doesn't like it if an address is an even address, so you get the famous guru. Then, so this should be here. We are clearing the 0. Normally, the 0 is used to tell which version of the library we want to open. So each kickstart has got various differences of the library. Now, I mean, Kickstart 1.2 and Kickstart 1.3, they are not called 1.2 and 1.3 for nothing. There is an update of the libraries, same as it is from 1.3 to 2.04. Okay, so it is sometimes you need, if you need a library that is only available in 3.1 or 3.0, you need to specify which library you need to open, because if somebody tries to run it on an Amiga 500 which doesn't have Kickstart 3.1 or 3.0, then it will have issues. Now the code will not run, so you need to make sure that the library that you open is available for the model that you are running. In our case, it doesn't make a difference. We're going to use just the normal standard Amiga library calls, which has been there since Kickstart 1.2. So we don't care what version of the library we're going to use. So basically, if you put a 0 in the 0, the library you can open any library. So we are specifying any version of the library. Okay, now the D128, sorry, D198, okay, this is a library that we need to find. So again, I'm going to do this. I think the text is not visible as it is, so I need to make it a bit bigger. Is it visible like this? Can you tell me before I... Yeah, okay, perfect. Thanks, Crane. So if we do, actually I better come to, let me copy this one and open it here. I tell you why. So I believe this is the right URL. If not, yeah. So this URL, which I'm going to paste in for you guys to use, is very important. Is where you find the Amiga reference manuals, basically, and you will need these for doing any coding in relation to the Amiga. One book that you will use a lot is the Amiga Hardware Reference Manual, which is here, as you can see, it is here. And then another book which is quite important and that you will reference quite a lot is the Include and Dodo Docs. The Include and Dodo Docs here of 3.5 is just, you will still need to come here because this just includes the amendments to it. So you will not find everything. So if you don't find it here, then you have to come here. But since we are using any library, and so it means it's there. So I'm going to use the Autodox 2.0. So what we are looking for is the so Autodox, I believe this is the right one, and no, sorry, references, yeah. And then, so we need references, and then we need function offsets, okay? Why function offsets? Um, is this the same? Yeah. Why function offsets? So each library has got a, you see this minus 198, that's the offset from the base of the of the library. So basically we need to look for exec, so we need to find the exec. So because if you see the numbers of the libraries, they do match. So if you look for minus 198, God knows how many minus 198s there are. So we need to look for the exec library, okay, in it. So there you go. This is the exec library. It starts from here, and as you can see, it says exec base. So from the exec base, okay, we need to find minus 198. So this part, see, you see, this is not a dash, but it's a minus, and then you have the address, the jump. So here it is. It's old open library, but this one, I checked it out yesterday. I can still show you, but this one does not is for the Amiga 1000 actually, I think, or before the Amiga 1000. That's why it's called old open library. Um, it was superseded by version 3.6. So if I go here, um, and let's go, so I'm back into, just to show you, I'm back here. So included on Autodox, and then exec. Now we get all the libraries, okay? You tell me why didn't you come here? Because here it doesn't tell me which reference number you cannot find the reference number here. You need to go to that page to find the reference number. So now we go to old open library, and you see this is what it says, okay? So this has been superseded basically, and it's better to use open library. It's better to use this one, okay? Which instead of minus 198, we need to find open library. So in this case, we do Control F, open library. There you go. So I'm going to copy this. Okay, you see this one has got the D0. So although our source uses minus 198 and we were clearing the 0, we were calling the wrong library there. That's reality. But we do make mistakes, like anyone else, like any coder, no? Okay, so what this says is A1 needs to have the lib name, which we did, and the 0 needs to have the version, which is 0, any version, so it's fine, okay? Once we call the library, we will store the address of when we open the library. We got like a pointer to the intuition library, okay? So we store the base, okay? So that's what it is, the base of intuition base, actually, store. Okay, so now that we store the intuition base, we can start doing something on the intuition. No? So that's how it works on the Amiga. From one library, you jump to another, you jump to another. It depends what you need, but you always start from the exec. So we need to understand what 5A is, okay? And in the intuition library. So let's bring back the books, okay? This time I need to go to, so we need to find intuition. I can do actually Control F, intuition. There you go. It was there in front of me. So now we need to find minus 5A. So 5A, there you go. So this is the library that we're calling. It is display alert. So this is the routine that we're going to call. Okay, so here we do display alert. We know that we're calling display alert here. And display alert takes an alert number, which we are moving 5 here. Okay, so that is, God knows what that 5 means. We might need to figure that out. So alert number. Here we're passing a string, basically is the alert, no? Address of alert. And here we're passing the length, I assume, of the alert. Sorry, height. So there you go, height. Okay, height of the alert. Height of alert. Okay, so we have a let's fix string because I do not like it. This is not a string, this is an alert. So alert box. So I think we can do LEA here, no? Yeah, I think makes more sense. And without the hash now, because we need the address of it. So alert box. Okay. The other thing is, this is calculated 60, which it means that every time I need to go and change the text here, I need to go and change the text there. So I do not like that. So on top of the source, I go and do alert size, then EQU, and then let's say alert start minus alert end. So now we are calculating the size and we pass that parameter basically. So this is just a constant, okay? So we don't need to calculate it each time. So here we enter alert size. And then I'm going to do alert start here instead of box. And change this to start. And here we do alert end, because it's the end of the alert. I'm going to ignore the following lines for now. I don't think they are used, to be honest, from what I've seen in the code so far. But anyway, and so we need to the alert size, yeah. And these we need to get them back to where they were. So we have done the alert. Now, this alert, we need the books. So let's find display alert, what it does. So remember, it's in the intuition. So go back and autodocs. Now we are not into the exec. Okay, we need to go into intuition, and we need to look for display alert. So display alert, there you go. So this is the alert box that we get. Maybe I should have executed the code so that you guys understand what it does, but I'm noticing that the code is not complete. I'm pretty sure this can be removed. I'm going to comment them out for now. I don't know, maybe this RTS is used. And I'm going to do, just in case, even. So just to make sure that we are in the right alignment, let's see if this code works. First of all, okay, so read the file. So we are in Phaze101, Twitch stream, and we are doing alert number 2. Yeah. Okay, so what did I do wrong there? Undefined symbol. So alert start, alert end. So alert start. Alert end. Why it's is the opposite way around. It's alert end minus alert start. That's the first thing. Minus alert start. U means update, so it's updating the code. But because it's shared, it took some time. So why do I not have single undefined symbol? Let's do that. Alert S, alert E. I don't like using short short names. That's the length of it. And we should use alert. Okay, so I'm assuming that this code displays another box. That's the first thing. Displays. Oops, I forgot to turn off the sound here. I better do that. Okay. So, as I said, those that are following me on Facebook, I recommend you to jump to Twitch and follow me on Twitch. It should be you get the links and all the stuff that I'm doing. Now, why is this not working? Oh, of course. Where's the code in here? Yeah, update, and still the same thing. Of course, now they are alert E and alert start. Still undefined symbol. Interesting. Something that is so simple is holding me up, and I cannot understand what it is that is holding me up. Any ideas? What I'm missing? Shouldn't be like that, but I can use constant. I do not like to take shortcuts, but yeah. Let's see. Yeah. Undefined symbol string. Okay, that we changed. So string needs to be alert s, and there should be lea. Why is I'm editing it here. I better go into the visual code. So this needs to be alert s and lea. That one. Now it complained about these. ll1. Going to call it loop 1. Oh, I already see something here that I should. Yeah, okay. Decrement and branch. Actually, not even that. Add 1 to D2. No, that has to be there, here. Yeah. Decrement and branch. And we need to decrement D1, comma, loop 1. So basically, instead of doing sub 1 and branch on not equal, you can use one instruction in the 68,000. So that one, this instruction I'm not happy with. God knows what it does. Because if it's equal, it's okay. It opens the alert, but if it's not, God knows what that function does. Okay, so what else it didn't like? So I'm going to, because the code is not to my standard, let's say that. So this is open library. Probably there's a condition when it opens it, but right now, let's leave it like that. Okay, I'm not happy with okay. Branch unequal, open, lib. Now, no. Why no? Why are you using no? So here displays alert. Ah, okay, so here if you press no, it does this. And then jump done. So why do you have an RTS behind it? After it, jump done. Doesn't make sense. So yeah, this should doesn't need to come here at all. If it's okay, so if it's okay, we'll see what that okay is. Open the library, display alert, then when does it say it's a no? Branch unequal. If it's not equal, it does this. It never comes to a no. Nah. This is something crazy, I think. But we do need declared 0 because we're returning to the OS. So the 0 should always be cleared, as it will get the OS will report an DOS error. So all these are not needed. At least so far, from what I can tell, those are not needed. Now, this compare. Okay, so let's do this just to make it a bit more understandable. This is display the alert. So the alert is always displayed except when the 0 is not equal to this number here, which that is a different story. We haven't seen yet what this does. So if it's equal, okay, then it goes to open it, then it goes to do our job and displays the alert, and then it goes out. I do not know why it had that code. I think that is extra code. Let's put it this way, which we know we do not need. Yeah, there's no references to VDU, there's no references to DOSLib, and yeah, we do not need those for sure. Okay, so here we have our data. I'm going to delete them, they don't make sense being here. Anyway, I have a backup of it, so it's not that I'm deleting something that I do not have. And this is all a code that is not needed. It's not used. Yeah. That's more neater. That's the first thing, because I was going mad, not seeing code neat. This, when you exit to DOS, Amiga DOS, unless you want to exit with an error, you exit with, you clear the 0, as it will display an error message. So clear the 0, so no message is displayed in Amiga DOS. Okay, so what remains is this part, and I have an idea what it does now. It's very simple. It's a checksum. This is a checksum, so that if somebody modifies this text here, it will not work basically. So what it's doing is getting so we can document it. Okay, so we're getting the address of the alert box. We are clearing the 0, so clear the 0. We are initializing it with 50. That's another thing which shouldn't be like that. It should be calculated depending on what there is. So the one holds length of our alert box. Now, this is the loop. Basically, what we are doing here is, I'm just going to do this and make a note here. So when we exit the 0 okay, holds the sum of all the data in the alert box. That's what it is. So, and then we are checking that it matches this number. So basically, if you had to come and count these, the 130 degrees to all our friends and contacts from 101, 0 and 0, that's what it's doing. Which here is 50. So even the code here has got an issue. So this is doing a checksum. That the alert box has not been modified with some hex editor. That's what it's doing here. Okay, so I'm just going to comment this part because I haven't commented it yet. We're basically understanding what this code does. So D2 is starting from the, we're clearing D2. So D1 is length of our alert box and used as a counter. D2, we are moving what's in 80, which is our alert box. What's in it? We are incrementing it and we're moving it in the 2. We are then adding the 2 to what's in the 0. So the 0 holds the checksum number. Holds the checksum. Which we can also see from down below. This is the 0 needs to match this number. So read data of alert box and if you are happy and store it in the 2. Not happy, and store it in the 2. Okay, now we're adding D2, okay, with the 0. I just realized something there. Let me check it. Give me a second, guys, because I need to take out a book. And see. Yeah, I thought you can. I think this line is not needed. We are moving a byte. Yeah, but then you have to do division by 4 because we are moving. Okay, for now I'm going to leave it, but we can improve it, and I'm going to tell you what we could have done. Okay. add dot long bracket 80 plus, because we are adding anyway the 4 bytes. The thing is, it will not match. Yeah, it will give us a guru, so we cannot actually do it. No, it will give a, it has to be byte, because it will, I mean, the length cannot be division by 4 always. So, and this will always read long. So no, we cannot use it. Sorry. Um, okay, so we read the byte at 80 and we stored it in A2. Then we are adding um, the data, the alert box data to um, to the to the 0, which is our checksum number, or counter, checksum counter, sorry. Is it counter or value, checksum value, because right now that's what it's containing, is checksum value. And here we should write value too. Okay, and then we are decrementing the 1, which is just a counter. So decrement the 1 and loop. Okay, so when we finish the loop, okay, we end up with a value in the 0, okay, holds the sum of all the data in the alert box, okay. Then we compare it to this value. So if we modify it, let's say instead of I'm going to do 102 just for or actually let's add, because it doesn't have phase, let's do phase. Okay, now the checksum has changed, and because of that this part of the code is never executed, and this part is never executed, and so because it's never executed, we do something here, but I'm avoiding it, what it does, and then we return to DOS. So basically you just return to DOS. Let's leave it like that. Let's say we return to DOS, because that FC002, I think he used a fixed absolute address, which he shouldn't, Crane, and God knows what that does. I'm curious to know what it does, but I'm not going to execute it because I don't know. It can be a format. I wouldn't be surprised. So no, just let's return back to DOS, or in our case to the assembler. But if it matches, then it's calculated. So let's save it. I hope you are understanding and you're finding this useful. Anyway, this is the first one, and to be fair, I'm quite enjoying myself about what we did. So it's quite fun to see such a thing. Even though it's a simple routine, it's a simple file that I just want to learn what it contains. So yeah, did I save it? No, not yet. Let's save it. Now let's go to the Amiga. So we need to reload the file because the Amiga is not intelligent as abort. Oh yeah, no, I could to ignore, continue. And you need to load it to get the latest version of what's in Visual Code. Okay, so there you go. This is our what we did. So assemble, no errors. So that was because we had some code which was nonsense there. The assembler was telling us, what the heck are you trying to do? Okay, so let's run it. J, we always have a backup of it. So the floppies, there you go. We did not match, we returned back. And the 0 contains the number F49. Okay, so if I go, okay, this is interesting. If I go and change this to F49 now with the word Phaze101, okay, remember we added it F49 and we update it, we assemble it, and we execute it. There you go. The text box is displayed, the alert box is displayed, and the checksum works. So that was a checksum. Yeah, but Crane, yeah, okay. So it's a reset, but for which? I don't know where you found it, but for which version of Kickstart? Because when you wrote this, you had Kickstart 1.2. So what will it do in another Kickstart? That's if you have a link of where you found it, please paste it because you'll save me time in looking what it is. But yeah, that's what it was doing. And if I had to do a reset, I think I will do it by using some one of the libraries. No, I assume there is one that does a reset. Um, I will not. I will not include it now because I'm not using Kickstart 1.2, so the library is changing. I have 3.1, so definitely the library is different. It will not work. It will crash probably. We can try it. I mean, all I have to do is restart the OS, and let's change it back. Let's change it to something else. Let's add Phaze101 group. Okay, so J. Mm. So this didn't work. So the checksum didn't work, but I'm not happy with the size. I need to measure this. What I'm doing there wrong, I do not know. So here, if I do alert E, I'm not going to execute, but I'm just going to see if it executes. Assemble, sorry. So that's the issue. It doesn't know. So how can I get? Mm, oh yeah, I know what I can do. Alert instead of having an expression here, I know what it's doing because it's a two-pass assembler and the first pass is not finding the labels. So if I do calc size, let's put that, okay, and then I go and do it will still not work, I think. Let's try alert S, alert E, minus alert S. Send me the link though. It's not right calling something direct, something absolute. Send me the link where you found it. Okay, so let's see. See, it's always having this issue. So okay, so let's do alert size. Let's do it here. So now, hopefully, hold on, I did a mistake. I better have even here. You see, it calculated it. So now we can use alert size. So that was the issue, that the assembler was trying to do a calculation. So this should be alert size. And we should have that fixed. Okay, that's our checksum. We can have that up here actually. Checksum EQ, and that should be $F49, and let's put checksum here. Okay, so I need to update sample yes J. It did not match. It did not execute the alert because, of course, let me assemble it again and see what number we get. So the 0 has 1220. So that should be our checksum now. So if we do 1220, 1220, assemble, Let's update first. Assemble J 1220 indeed 0. I think that has to be like that. Stupid mistake. Yeah. So it worked. I did the update. So I'm going to go back to Visual Code. This should have what we said. Okay, and there's the equate for it. This should be delete tab, better like that. That is fine, and that should be even there, and even here we don't need. Yeah. Okay. So, so let's do something here. Open library. If execute this code. Do I note? So okay, we know it's going to open library, but note code executed only if checksum matches. So I have a question for you, Crane. You are saying that it's a reset. You haven't told me how you know that it's a reset. So I'm asking you to tell me how you got to know that it's a reset. Don't tell me you remember it from your memory, because yeah, on Kickstart 1.2, yes, but I do not know what it does on Kickstart on the other Kickstarts. So displays an alert box if checksum matches. If checksum matches. Okay, so instead of open library, do open library, just leave it there. That's where it continues. If not, just return to DOS. So continue. Compare the number. I'm going to say do something if code doesn't match, and then this return to DOS. So this is the interesting part now. I'm going to save it. I'm going to assemble it. So back to the Amiga. So read, because we updated it, read the file. it has all that we wrote. Assemble J. So we 11 dB now. What did I change to have 11 dB? 11. It was longer before. dB. 11 dB. Update assemble J. Okay, so that's working. So we assembled it, we know it's working. That's all it does. However, we're going to write it, okay, as a file. And I'm going to save it in my temp directory. Okay, I'm going, yeah, alert2.exe, like Windows, to make sure it's an exe. Okay, so now let's exit the assembler. We don't need the assembler anymore. We open Z shell. Okay, we go to temp. Okay, we should have our file there. Yeah, alert2.exe. So if we do alert2.exe, there you go. Our lovely message box that basically we created a command in a way. Imagine the text file, you can load it from a file if you want, and you just display it as a command. So this is another idea. I mean, I'm pretty sure that somewhere we have load text file or load a file. So yeah, it's simple. And we return back to the OS. If the 0 did not have was not cleared, we would return with an error. So that's why I was clearing the 0. Of course, if the checksum doesn't match, we should do something there. But for now, that's what it is. Now, what I didn't cover is how the alert box is built up. Okay, so let's read the same file. And we will discuss this, what we have here. Actually, let's do it from Visual Code. And let's see what these mean and what we are saying. So you specified 100 here. If I remember correctly what it does, that 100 is not correct. That's why when I run it from the OS, so I don't know if I'm going to run it from here again. Notice what's going to happen. It's going to start somewhere here and then it moves up, because that you are able to do in Kickstart 1.2, but not anymore. So this is why I don't like using absolute addresses. And since I'm on a stream, I do not want to give the wrong impression or the wrong answers. Using absolute addresses is wrong on the Amiga. So this is why I was asking Crane to give me from where he's getting it. I think he just remembered from his memory, but that is not good practice. So that's why I'm avoiding of using FC00D2. So let's execute it again. Okay, and you're going to see that I think it starts from the middle of the screen. It was too fast, but you could see it move. I could see it moving. Too fast. The first time I did it, I saw it moving from the middle of the screen going up, and yeah, don't worry. Let's continue. So now we need our famous manual, okay? The alert box. So we already know what these are, okay? We already specified this alert number. That alert number, we do not know what it is. Before he was specifying 0. I mean, in yesterday's stream, Crane specified 0. In this one, he specified 5 for some reason. But I do not know what that 5 is. And this is the process. This is what this stream is about learning what our code did. I know I'm going to find lots of things that were done direct instead of using a variable and say what it is and all that stuff. Unfortunately, 32 years ago or 35 years ago, that's how we wrote code. We were kids. As long as it worked, I think we didn't bother that much. Something like Jeff Minter did, in his code. When I see this assembly of his code and how some of this code is the same thing, same principle. Okay, let's ignore the 5 for now, the alert number, because I'm pretty sure here alert number is a long value historically related to the value sent to the alert routine. Okay, but what this value means, nobody knows. But the only bits that are pertinent to this routine are alert type bits or bit. These bits must be set to either recovery alert for alerts from which the system may safely recover, or dead end alert for those fatal alerts. These states are described in the paragraph above. Yeah, dead alert and recovery alert. So somewhere in the include files, there's a definition of these, okay? These states are described in the, I read that, sorry. There is a third type of alert, the DAISY alert, which is used only by the exec. So basically, the DAISY alert is used by, of course, it's used by the exec. It's when you see lots of, you get the guru, then you click it and you get another guru. Basically, it's a chain of things. While in our case, we will not have such a thing. And I don't think you can program it, to be honest, like that. But anyway, so that 5, for now, we need to ignore. Just assume 5, and we will modify it in a minute. Because we should not be passing any alert. It's something that we created, so it should be 5. It should be 0. The string argument, so now he's still describing this one, the alert s. So, and he's going to say what alert s, what format we are expected to have or find in alert s in relation to this. So the first value, okay, is a 16-bit x coordinate. So we copy this. So this is a 16-bit x coordinate. So we take notes of that. and we put it there. Oh, I didn't copy it. Let's move this, make it half of the screen like that, so we can work better. So that's the 16-bit value. Then we have the 8-bit Y coordinate. Then we have our message. So then the bytes of the string itself, and it must be null terminated. So here we should have a 0. But if we have a 0 here, that means the 0 need to go. Okay, and it makes more sense because that's the null terminated number. Lastly, the continuation byte. So basically what is going to say here, if this is 0, there's no other strings. But if this is, it can be any number between 1 and 255. If this is 255, then we can have something like this. Again, okay. Oh, I have a mistake here. To display in the alert box. So then we need to specify this again. So we can try it out actually. So like that, we have two strings. So we're telling it, do the first one and then do the second one. Okay. Last one, we said it, and then the height. Now the height, we're still talking. So he explained the manual is explaining the string alert s, okay, and now he's explaining the size, alert size, what it is. Alert size. Where was it? Lastly, the continuation byte, yeah, which we did. The last argument, height. Okay, I'm reading here now. Okay, so these three we're describing here. Okay, now we are doing the height, which is the value that we put in the one, which is expected in the one. Okay, so as you can see, these are in which registers you have to put the values. Okay, the last value, the last argument, height, describes how many video lines tall you want the alert display to be. Okay, so interesting. We are saying, what is our alert size? Because here we calculated the size and I'm using it again. So this is how many bytes it has, but actually this is not how many bytes it has, but how many raster lines it has. So we can say, so it's 8 for sure, and another 8, and then there's a space in between, that's another 8. So we can say, I'm going to remove this alert from here, and I'm going to say, so it's 8 characters now. One character is 8 scan lines. So 8 times 3. Let's see what it does. Maybe it has to be more, but let's see. Let's save it. And let's go to the Amiga. Reload the example. Let's see that it did what it is what I'm saying. Yeah. What have I do? What did Let's go back in here. It's easier to edit. So, first of all, remember this is a word because we specify it's a 16-bit. So why it's saying 100 is an issue? It shouldn't. It's 100 decimal, not hex. This has to be, this is where it starts now, so this has to be 150, let's say, right? I'm just experimenting right now, so, okay, let's do it like that. Now we go to the Amiga again. We need to read it. Assemble, still. Word at, oh, Jesus. Okay, of course. I didn't see that. Word at address. But that should be a word. So, interesting. So if we make another 0 here, yeah. So how can you calculate? How can you always make it even like that? Okay, I know what you need to do. Just in case. You always have to insert the word even here. Just in case. Jesus. So you need to have even here. Just in case. Always after a string you have to have even. Yeah, I can put an extra space, but I want it to work whatever I write instead of having to put an extra space or calculating or things like that. So that's how it should be. But then the continuation byte is going to happen. Okay, let's see what it does there. Let's see what it does. Hold on, which line did it say? 75. Yeah, of course. It had to have. Nah. So the issue is here, between here and here. Even. That's the issue. Funny enough. Yeah. Let's see. That's what I'm thinking, that an even is going to break the structure. But even if I put something else, it might break the structure unless I put it in the text string. So I'm just going to execute it and see what it does. Of course, the checksum doesn't work. So right now I'm going to do something. Jump, open lib, as I will have to do the checksum each time. Yeah, it didn't like it. So that's very odd. So yeah, it does break the structure like that. So you need to have an extra space somewhere to make it work. But then I'm not sure. Let's put it 100. But this one should be higher, no? This should say, let's say V50. It's the Y. So update assemble J. Let's see what happens. Nah, it lost the format. So what is wrong with these values? Yeah, I increase the height. Ah, because there I have ×3, no? Oh yeah. This has to be like ×10. You are paying attention, Crane. There you go. So we have, let's see how many. I have 1, 2, 3, 4, 5, 6, 7. Is there 3 spaces from top and 3 spaces from? You see, and the group with the space looks odd. Anyway, we are learning how the alert box works. So I do not know why you need to specify these. Seriously, I do not know. Why do you need to specify these? When it always go in the top left right corner. Why you need to do this? I mean, if I do this to 100, no, I'm going to leave it 100 as X. Let's do this to 30. Okay, it's at the bottom of the screen, and let's do to 50. Okay. That's where the text moves. So the box is always on top, but the text is not. Yeah, the height possibility, I understood. That was the issue. So now, if we have 2, so instead of 210, I could have put 5. No? But this, okay, let's make them the same. By having a space here, so it doesn't look so odd. But these are moving down, so this is, let's say, 8 times 1 should still work, and this should be 8 times 3. No? So yeah, times 1 is on top. So if we do times 2, because the first character is used for the border, no? And this times 4. And we did it 5, no? We did 5, yeah. So 1 is the border, 2 is where our first text will appear, then 3 is not used, and 4 is our text, and then um, um, the other border. So it's perfect like that. Yeah. No, it's not 3 and 5. It's 2, and the border is at 1 and 5, and the text is at 1. Sorry, is the border is at 1 and 5. The text is at 2 and 4. Yeah. So if we assemble, we should have it in the middle now. Okay. Yeah, exactly that. Yeah, that's what we were after. Yeah, I changed the space. So yeah, but to be honest, that concatenation thing should be not a. It's using byte, so then when the word comes for the 16-bit value, because it's not word aligned, it's an issue. So the string here is an issue, the first one. But anyway, it's one of those things. Good exercise though. So this is on which line of text it is displayed. That's why we are using 3, no? How long have I been streaming? Oh, nearly 2 hours. 1 hour, 53 minutes it's saying here. Wow. To understand this simple code. But anyway, we did learn some stuff here. Okay, the assembler for some reason is being funny in terms of the tabulation. It's not taking the same tabulation, so let's go here and fix. For some reason there's something here that it's not liking. Okay, so what we didn't do, we left this as 5. I'm going to do this as 0. I'm just going to name this part as display alert, even though we are not calling it, but it makes sense. So yeah, that's why we could have done it differently. So yeah, but we can leave it as it is. I was thinking of, instead of branch on equal, we could have say branch on branch or not equal, then if it's equal, we do JSR open lib. So it returns, so it always exits. The program is, so what I'm not liking is that the program is exiting from here and from here. Where is it? This one, which actually it's annoying me. I'm going to do it. Because it shouldn't. You should exit from a program from one place, not from 1,000,000 places. Okay, and here branch on not equal, we call exit. We have exit here. And this should be also there. So that when we exit, we always clear the 0, and then this one jump to subroutine and open lib, or display alert, open lib. Yeah, open lib. Did I say it is open lib? Open lib, yeah. So now, not do something. Now this became misleading. So although it's open lib, it's here it is display alert box. Display alert. So display alert, but we have another this display box, alert box, just to more alert, leave it alert. So now we have to say here exit, no match, so exit, no match, so exit, match, so display the alert box. And this one should be changed to alert. I think we do not need this anymore. Actually, leave it there for now for testing. Yeah, but now we will, because I changed the logic there, now it cannot be like that. So I think we have done everything that is required. We have documented it fully. I mean, we could use equals here instead of EQ, but whatever. And here I could even use, I do not even need, yeah, actually, I think this will work anyway. If I do this, 10, 10, 10, 10, that should work. So let's not start another one. Use what I have. So R, assemble, yeah. So this star does work. So now J, of course we are not matching, and Y did 0. The 0 has got nothing in it, so we execute it. Interesting. What's our issue now? So alert size, we know we are calculating, so this is not needed, but anyway. Yeah, star, where we are, minus alert s. It should tell us the size in bytes of, so why it didn't return a value in the 0, so we must have some error here. Oh, we are clearing the 0 always now because we exited from here. So let's see, the checksum now is different. Yeah, stupid me. So assemble J, and the 0 has 24 AD. Okay, so now that's the actual checksum, 24 AD. Because now we have 24 AD. So now assemble J, and the 0 is, of course, because I cleared it up again, 24 AD. Let's not clear the 0 before we exit. So we know how we exited. So I did 0 equals 1. Hold on. The 0 should have the sum of all of them. So why did it say 1? Okay. But it's executing, so that's correct. Okay, yeah, it's correct. Oh God. Now it's telling me what I pressed, whether it's the left mouse button or right mouse button, but that's a different story. So now if I run it, assemble J. Interesting. Assemble J. And it executes. How can it be? JSR display alert. So display alert. And it does these two and returns. So why, if I clear the 0 here, it doesn't execute? I mean, the compare should happen before. Hmm. Printer not equal, exit. But if it's equal, display alert. However, display alert is not being done. Um, this is tedious. What is the issue of it? Why? Why did 0 is making it not work? Just putting the remark here and we're just cleaning the 0. Has nothing to do. There is no this. This is annoying. So yeah, but let's go and modify the code anyway and update it. Sometimes you need to not look at it and then it will appear. So this one we do not need anymore. We know it's being calculated. Um, so it starts executing here, comes here and returns, and it returns here. There's no other jump to subroutine or some more jump. So I do not understand why this is the issue. Interesting. Okay. Let's go back. Read I, J, and it doesn't execute. But if we, how can it be possible? Branch or not equal, exit. If it's equal, to the JSR. Incredible. Adding the clear. What I am thinking of is strange thing can, oh Jesus, strange things can happen. I need to do it like I do on the PC, shift arrow. No, it cannot be shift arrow. It is Control B, Control X, Control V. Update, assemble, J. Now it didn't execute it, but we know that the 0 to 4BF, to 4BF. Oh, to 4BF. What did I change to make it not? I changed the, of course. So escape, update, assemble, J. We will fix that thing. So let's copy it, X. Control V. Okay, let's see now. Update, assemble, J. Yeah. Okay, so we now know what that I had the checksum was not working properly. Not working properly. We had the wrong number, wrong value. Yeah, because I added a yeah, because I added a space there. Yeah. So if I add a space here now, okay, update, assemble, J, boom. It didn't run, but as soon as I remove the space, update, assemble, J, there you go. Okay, so for those that are still following me and haven't slept, basically this small little program from our collection of sources is basically, I'm going to go through it very quickly. So here, this one, okay, this part of the code, we are having a check to see that the alert box was not tampered with. If it matches the checksum, we display it. Okay, so that's one. Then we are opening the library. Okay, open library, and we are from the exec base, and we're getting the intuition base. Okay, from there we display the alert. Okay, with our information down here. So this is our display box, alert box that has got a value of where it starts in X. Doesn't make a difference, I think, in this case, because it's fixed. But anyway, you can probably shift it a bit, but I'm not sure. We can try it actually while we're still at it here. Let's do 80 and 80 because they have to be the same, I assume. Escape, A, J. Of course, the bytes has changed. So, okay, let's leave it 100 and 100 because as it will not work. As soon as I change these, because it's calculating all these, no? So it was tampered with, it will not work. So now if I assemble it again, and J, yeah, there you go. So, and this is our format of the alert box, okay? That's basically it. It's a source that this was a test source for something else that was used in something else. But most, and as you can see, we had an intention of using it. So it's part of a small test. This is how we used to do things. We used to always test, the code, break it in chunks and test bit by bit. I mean, even I used to do this. Let's say I want to do a scroller. I would not start writing the code from A to Z and expect. So I would do the first part. Let's say open a screen. So I have the screen. Then maybe load a file. So I have the load file and I test the load file separately from my code. Then I merge the code, my open screen, and load the code together. Then I have display picture. and it's the same thing. And you continue building it like this. So these are tests that we were doing, so that we know where, if we have issues, where they are. I hope you liked, you were able to follow and liked this series. I know it's a bit late. When I streamed, I would have preferred streaming earlier, but I just wanted to start. I might even stream tomorrow, but I don't know. I will try to keep Friday for this. I will stream earlier, not at this time, but it was just the first initial test, and I hope that people will follow um, or like this stream like they like the other one of the 68,000. So if you are on Facebook or on Twitch, please, if those that are on Facebook, please join and follow us on Twitch. And those that are on Twitch, if you haven't put a follow, please appreciate if you can put a follow to our channel, because for the sake of Twitch, in a way, I need to get more users. Let's put it this way. Thank you very much, and bye bye.